Hey guys, welcome back to our channel. This channel, Vivid Science, is all about trying to learn various concepts of data science by practicing a lot of questions. In this video, we are going to solve this question on Leetcode regarding find drivers with improved fuel efficiency. The difficulty level of this question is medium, and I'm going to share the SQL schema as well as the Panda schema in the description box below. Okay, the question reads, we are given a table called drivers with two different columns, driver ID and driver name. Driver ID is the unique identifier for this table. Each row contains information about a driver. We are also given a second table called trips with five different columns, trip ID, driver ID, trip date, distance in kilometers, and fuel consumed. Trip ID is the unique identifier for this table. Each row represents a trip made by a driver, including the distance traveled and the fuel consumed for the trip. We are asked to write a solution to find drivers whose fuel efficiency has improved by comparing their average fuel efficiency in the first half of the year with the second half of the year. Calculate the fuel efficiency as distance kilometer divided by fuel consumed for each trip. So this is very important. First half is January to June, second half is July to December. Only include drivers who have trips in both halves of the year. Calculate the efficiency improvement as second half average minus first half average. Round all results to two decimal places. And then return the result table ordered by efficiency improvement in descending order and then by driver name in ascending order. Okay, let's go to this example. Here we have five different drivers and then their various trips, trip date, distance kilometer, fuel consumed, and so on. So if we look at driver ID1, so driver ID1 has trips in the first half of the month because you have February and March, and then second half 8th and 9th. Secondly, if you calculate the fuel efficiency of each of the trips, so for example 120.5 divided by 10.2, that would be somewhere around 11, like close to 12, 11.9 or something. Similarly for this as well. And since in the first half you only have two of the trips for driver ID1, so you get the fuel efficiency of like trip 1, trip 2, and then you get the average that will give you the first half fuel efficiency of driver ID1. Similarly, you can do that for second half, and if the second half is more than first half average, then that should be included in the output. And similarly, we can do that for other driver IDs as well. So we have driver ID1 whose first half average was 1197, second half was 1402, and this is the improvement. So to solve this question, what we do is we can start with the trips table, and for each of the trip, we need to calculate the fuel efficiency. Why? Because the question says so, that calculate the fuel efficiency for each trip. So let's start with it. From this table called trips, what we're going to do is let us return all the columns. So select star and just simply do distance in kilometers divided by fuel consumed. That gives you the fuel efficiency. So fuel efficiency. Let me go ahead and run this. Let's see what do we get in our output. Okay, so now if you look at our output, what do we have here is we have for each all the necessary information from the trips table and the fuel efficiency calculated. Now what we want to do is we want that for each driver ID, try to find out the average fuel efficiency for first half as well as the second half. How can we do that? We can save this entire thing in a common table expression. So with CTE as, this entire thing goes into parentheses, and then what we are going to do is from this common table expression, let us group by the driver ID, because for every driver we need this, right? So group by the driver ID, return me the driver ID, and now case when your month from the trip date column between 1 and 6, so that means it is the first half. So then you return me fuel efficiency, else you return me null, right? So else you return me null. Since you started a case when statement, you need to end this and basically calculate the average of this entire thing. This will give you the first half average, right? First half average. Similarly, what we can do is we can just copy paste and just change the months and that will give us the second half. So if it is between 7 and 12, then fuel efficiency, else null, and end. This is basically second half average, right? Let me go ahead and run this. Let's see what do we get in our output. Okay, so what we have here right now is we have various driver IDs, their first half average and second half average. In the final output, we also need the name of the driver, right? How can we get that? We need that information from the drivers table. So here, what you can do is you can save this entire thing in another common table expression too, and then try to perform a join. But instead of doing all that, what we can do is from this common table expression that we initially had, which had the fuel efficiency part, we can simply go ahead and join here from CTE as C. Let us perform a left join on the drivers table aliased as D on C dot driver ID is equal to D dot driver ID. Now, since we have driver ID in both of the columns, so if you just run this, it is going to give you ambiguous column names. So you need to specify this driver ID comes from which of the tables. So C dots from common table expression. And since there is no, repetition of the trip date column or the fuel efficiency column, we should be fine. Here also you need to make sure that you are grouping by driver ID, as well as we need the driver name in the output. So let us do d dot driver name as well. And that should be in our output as well. So we just copy this, paste it here, and let me go ahead and run this and let's see what do we get in our output. Okay. So if we look at our output right now, let me just drag it to the left. So we have the driver ID, name, first half average, second half average, and in the output, we only need people who have averages or trips in both of the halves. And secondly, the second half average is more than the first half average. So all these things can be taken care by just one line of code. Let me first, you know, save this entire thing in second table common expression. So CTE2 as this entire thing goes into parentheses, and then what we need to do is we need to make sure that okay, from this common table expression 2, we only need those people or those drivers whose second half average is greater than first half average. And since in cases like these where you either don't have first half average or the second half average, this comparison will filter these rows out. So if I just go ahead and do this, right? So select star, you are going to see that only Alice and Bob Smith remain. So you see in our output what we have is Alice and Bob Smith. And since they have trips in both of the halves as well as the second half average is more than the first half average. Okay, we also need to get the efficiency improvement, that is second half average minus first half average. So second half average minus first half average, and this entire thing should be aliased as efficiency improvement. Let me just copy it and paste it here, and this is what we have. Okay, if I go ahead and run this again, so we have the desired output. The reason why it says wrong answer still, because the question also asked us to round all the results to two decimal places. So basically what we need is we need the driver ID, we need the driver name, then we need the first half average rounded to two decimal places. So round first half average to two decimal places and alias this as first half average. Then round the second half average to two decimal places and alias this as second half average. And also the difference or the improvement. So round this entire thing to two decimal places and alias as efficiency improvement. Also, the question mentions that we need to sort this result as well. It should be sorted by efficiency improvement. So order by efficiency improvement in decreasing manner and then by driver name in ascending order. Let me go ahead and run this. Okay, so this is accepted. And if I look at our output is exactly same as expected output. Let me go ahead and submit to pass all the test cases or not. So yeah, this is accepted and this is how I do it. So, yeah, tricky question, but what we basically did to solve this question is, firstly, for each of the trips, we calculated the fuel efficiency. Then we calculated the first half average as well as the second half average by making sure we use the month extraction from the trip date column. Once we had that, for each of the driver ID and the driver name we got from the driver's table, we joined it with the common table expression we had earlier to get for each driver ID and driver name what's the first half average and the second half average. Then what we did was we made sure that the second half average is greater than the first half average. This also took care of the condition that we wanted only include drivers who have trips in both halves of the year. And then we calculated the efficiency improvement by subtracting first half average from the second half average, rounded all the results to two decimal places, and finally sorted by efficiency improvement in decreasing manner and driver name in ascending order. So yeah, this is how we do it. Let me know if there's a better, more efficient to solve this question. Let the solution be in the comment section below, and I'll see you guys in the next video.